Hi everyone, my name is Pedram Navid and I'm the head of data engineering here at Dagster. And today I want to talk to you about how we can stop reinventing orchestration by embedding ELT into the orchestrator. So first, I'm going to talk a little bit about the data engineering lifecycle. Data, it begins in the generation stage. This is where data is created. And then from there, it goes through various different steps along the way, from ingestion to transformation, serving and storage, and then finally ending up in places like, analytics, machine learning, and reverse ETL. And what I found is that, over the past few years, we spent a lot of time and investment and energy in making parts of this life cycle better, but we've tended to ignore the ingestion side of things. So while tools like dbt has made transformation better and DuckDB has made it easier to deal with things like storage, on the ingestion side, I feel like we still don't have a great story. And I think this is really exemplified by this tweet here by Carlos. And he kind of talks about how we used to have this world where all we really needed was a Postgres replica, and we could just select star from our table and do some analysis on top of it, and things were good. But as the modern data mess has sort of grown, we've started to see that things are not so simple anymore. And why is that? Like, why has things become so complicated? Well, I'm going to argue that one of the problems is that we haven't really done a great job with data ingestion. And if we think about data ingestion, it really happens in like one of three ways. We have databases and warehouses, and this is where, you're probably familiar with things like Postgres and Snowflake and MySQL. This is where your data resides in some type of structured place. And it's often, backed by SQL. There's not a real API you need to interact with. There's a lot of volume as well. And so you have to think carefully about backfills. But overall, I would say, these types of data ingestions are kind of standardized in terms of the things that we tend to think about. On the flip side, we have APIs. There's like a long tail of solutions here. These could be, third-party SaaSes or some other custom API you have to hit in order to get some data. There's very little standardization here. There's many different endpoints. You could be using REST, you could be using GraphQL, and there tends to be a lower volume here as well. And then the final thing is, the other grab bag of data coming in from all types of places. So we have like your FTP, we have flat files, sensors, IoT logs, and all that. Today, I'm going to really be focusing on database and warehouse ingestion because I think there is a fundamental difference between these different types. And I think in a lot of ways we do ourselves a disservice by kind of categorizing all of these different types of data under one ingestion umbrella. And let's talk a little bit about why it is hard to do ingestion, right? Like, um, let's say you have data in your Postgres database and you want to, take that out and put it somewhere. Well, for the most part, you have three bad choices, right? You could start by, rolling your own ingestion solution, and that's okay, right? But a lot of the times you feel like you're reinventing the wheel from scratch. It's not quite clear like what the best way to do these things are, and it's not really a place you want to spend a lot of time. The other option is you think, okay, maybe I'll use an existing framework. The problem with these frameworks is that they can be quite heavyweight, large, and onerous to set up and build and maintain. What you're really looking for is something a little bit more lightweight, but what you end up with is like everybody here, for example, there's 11 different services running just to pull data out of a system and into somewhere else. And so you may opt for the third solution, which is paying for a managed SaaS solution. Now, this seems okay, but then you start to look into their pricing models, and often they're billing you by the row. And when you have a Postgres database, that can be quite expensive. And if you do a backfill, for example, now you're re-syncing all of those rows and being billed for every single one of those rows. And you can end up with surprise bills as well, which we don't love. And so if that's the state of things, like why is it so bad? Like one of the questions I have all the time is like, what is so difficult about ingestion? And I've kind of thought through six different uh, things that make ingestion difficult for us. First is observability. This is really about being able to observe, get logs, and understand how data is flowing through your systems. It's really you need this in order to start any type of data pipeline. And then there's error handling on its own, probably not too difficult, but something you do need to take into account. Things will fail. Your database connections could fail. You might drop a network connection, and being able to gracefully handle this is very important. There's also state management, which is really all about, how do I make sure that I'm not selecting star from my table every single day, because that can be very wasteful and slow. And so if I'm running, these things every single day, I need to, capture that state somewhere. And that's again, not difficult, but it is something important to do. And then we have this, data quality concept as well, right? Like we don't want to just take the data and publish it immediately. We might want to do some audits and some checks before it is published to make sure, it meets our quality criteria. And then we have things like type conversion and schema drift. These are the types of things that will happen that like you sort of just have to handle and deal with, right? Your Postgres and your Snowflake will naturally have different types, and being able to translate between these two is very important. You might use one type of date time here and a different type of date time there, or different type of string handling. And finally, schema drift is all about how schemas can change, right? Especially with databases, your schemas are changing all the time as your engineering teams are adding columns, dropping columns, changing types. And so having a way to handle these things is very important. And when you look at it, like there's really these two types of categories about these concerns, right? On the first side, we have these orchestration concerns, observability, error handling, state management, data quality. These are things traditionally an orchestrator solves. And then on the other side, we have type conversion, schema drift. These are things that are really well handled by some ELT libraries. And so the question is like, do we have to have all of these things in one place? Well, we absolutely need all of these things. And because of that, that's why we've seen tools like Meltano and Airbyte, package everything together. But then we end up with that mess where we now have 11 services to monitor on top of everything else just to manage data transfers. On the flip side, if we go with some of these smaller tools, we'll find that they handle the library concerns really well, but we're still finding that we're without the orchestration concerns. And so managing data quality and observability can be quite tricky with just a small library. And I think what we can do is maybe take a lesson from DuckDB. DuckDB did this wonderful thing where they said, we love analyzing data, but maybe we don't always want to take a giant warehouse, and that kind of feels a little bit heavy for our solution sometimes. And so maybe if we could take a small embedded library, we can do some of these common routine tasks that we've been meaning to do, like ingest a lot of CSVs and do analysis without having to resort to like a Databricks or a Snowflake or Spark in order to do that. And what we've seen is actually there's quite a bit of other ELT libraries that have that same philosophy, right? There's tools like Sling, DLT, SteamPipe, PG2 Parquet, Cloud Query, Alto, and all of these tools, they do a really great job of being small, lightweight tools that solve the use case particularly well. But then when we have those, we come back to the same problem, right? It's like, well, we have these tools, well, how do we sort of orchestrate them? And that's kind of the topic of our talk today. I want to talk to you a little bit about Dagster Embedded ELT. What we're happening here is like we decided if we already have the orchestrator, Dagster, what if we could leverage that with these embedded solutions? Would there be a way to make a better ELT solution? And we really believe so. By introducing this, we were really building on the spirit of DuckDB and these embedded solutions by providing a better developer experience, wrapping around some of these libraries to make it easier for you to ingest data. Well, why embedded ELT in the first place? Like, why not just use, one of these bigger solutions like Fivetran or Stitch or Airbyte or Meltano? We really believe that ingesting from HubSpot and Google Sheets is really different than ingesting from Postgres, right? These tools tend to do it all. And because they do it all, we feel that maybe the concerns are a bit too general. When you look at HubSpot and Google Sheets, those are, we would say probably better served by these tools. But when ingesting from Postgres, that's more of a data engineering concern. And we believe it's best served using an orchestrator that understands data engineers. And the other piece is we don't think backfill should bankrupt you, right? We don't want people thinking about whether or not a column got added and whether that's going to cause an explosion in a build the next day, right? Having to backfill shouldn't be an expensive proposition. And then finally, we believe that embedded ELT is really the ultimate way in which we can solve these use cases that are, generally quite expensive, but maybe not necessarily need to be. And so let's talk a little bit about what Dagster Embedded ELT even is, right? It's a Python package that you can install using pip install. And really in one line, you can import Sling from Dagster Embedded ELT. Sling is one of the many libraries that are out there for ELT. It's the first one that we're choosing to support today because of how easy it is to set up. And what that actually ends up looking like is you really use a few lines of code to define your resource. So in this case, we're taking data from Postgres and we're sending it to Snowflake. And so all we do is, wrap our data in a source connection and a target connection, which helps us identify the credentials which we need. And from there, once we have a resource, we can really just create this asset, which will sync data between these systems. And so you can see on the screen here, there's not a lot of code involved, but this works, and it's almost hard. I still don't believe it to this day, but it works, and it works quite well, right? All you do is define your asset, and then you use this build sling asset function to generate the asset, right? So we give our asset a name, and then we say we take the data from public.events and then write that to raw Postgres events in Snowflake. We'll say we want to use the incremental mode, and we provided the primary key, which is just an ID column. And so if that seemed, too easy for you, I think what I'm going to do actually now is to do a live demo and show you that this is actually possible and quite nice. So let's get started. Okay, we're going to do a quick demonstration of how Dagster Embedded ELT can make it very easy to just take data out of your Postgres database and write it to S3 and create a very simple data lake. Now, here we have, just 4 basic assets. Our first one here is the seed Postgres asset. And all this is going to do is generate some fake data into Postgres for us so that we have something to work with. So I'll click this one off and I'll let this materialize while I walk through the rest of the assets. So once that's done, the next thing we're going to want to do is run web events. This is our core Sling sync, and this is going to use Dagster Embedded ELT to take all that data from the web events table in Postgres and write it to S3. Now for this example, I'm using MinIO, which is a very small, light S3 service that runs locally on your computer, and it just mimics S3 without having to worry about all the S3 nonsense, right? So once that's done, we'll have some data in S3, and then the next thing we're going to want to do naturally is take that data and use DuckDB to query it, create some tables, and do some analysis. So as you can see, the seed Postgres one is already complete. We take a look at the number of rows over time. You can see how that's changing, and also that the asset check has passed. So once that's all good, the next thing we're going to do is run web events. And this is going to be really quick. That's how it's so fast, I can't even believe it. I'm going to click view. You're going to see it run. It's writing to S3. It's complete. And it wrote a bunch of rows right here, as you can see that of the asset. Let's open up the MinIO console just to make sure, right? So it was empty. I'm going to refresh it. We can now see the folder right here, and we can see the Parquet files have been written. So that's already a data lake created in just a few steps. So easy. I can't believe it. And I wrote it, and I still can't believe it. All right. Next, we've got page views and top refers. Let's run these both together at the same time. This is going to use DuckDB to query those core data sets in the Parquet file, and then materialize those as views, and then create a little table out of that, out of like the top refer paths. While that's running, I'll actually walk you through the code real quick. Let's pull that up, and here it is. Perfect. So our resources are quite simple. We really just have, a Sling resource which defines, your Postgres connection, and then your S3 target connection, your source and your target. That's all really that is. I also have a Postgres class here, which is a simple wrapper around Postgres that lets me do some Postgres querying as well. On the asset side, I have the seed asset. This was the first asset I talked to you about. And what this does is it lets you write data into S3 just using a simulation of data just for our sake here, right? And then once we have that done, we have this asset check here, just making sure that the rows are written and everything looks okay. And really, this is the core Sling functionality using Dagster Embedded ELT. We're just telling it what the asset name should be, what the source is, what the target is, and then what format we wanted. In this case, we're saying Parquet. And really, just in these like 5-6 lines, that's all it takes to take data out of your database and into an S3 location. So it's quite nice, quite simple. And then from there, we can use DuckDB. As you can see here, we're querying that same location that we're writing the data into, defining the JSON schema and all that kind of fun stuff, pulling out that into a table, and then finally doing an asset check on that, and then looking at the top paths and mediums and counting those from page views. So that's really all it is in a nutshell. Let's take a look at that materialized in Dagster. You can see here, there's actually a preview of the data, so we can see how many events by path and by medium. We can see how this has changed over time. So you're really getting a sense of like how easy and how quick it is to use Dagster Embedded ELT with the Sling library to just get some data in and out of these systems. All right, let's cover what we talked about today, just to wrap up, right? we talked about how data ingestion is a core part of the ELT pipeline, but it hasn't really gotten a lot of love lately. And so we know that there's really three ways to ingest data typically, right? We can either write our own solution, which can work but has its own set of downsides, or we can rely on some of these heavy frameworks that tend to come with a lot of cruft and maintenance burden, or we can just offload that to a paid managed service provider, and they can, you know, do the ingest for us, but they will charge us for every single row that gets changed, and that can get quite expensive, especially when it comes to backfills. And so, what we've done is we've taken the best of these lightweight tools and wrapped them with the orchestrator that you already know and love today, and we created Dagster Embedded ELT, and we saw how in just a few lines of code you can solve these core data engineering problems that we all have. And so I do want to emphasize that this is still a very early release. This is an early product. We'd love to get your feedback on what you think, on what other tools you think we should be supporting as part of this framework, and let us know what you think. And thank you so much again for joining us here at Launch Week.